Hi everyone, today we're going to be talking about section 12.2, which has to do with measures of central tendency. So when we have a given data set, there are different ways to think about where the middle of that data set is. We're going to consider 4 different measures today: the mean, the median, the mode, and the mid-range. The mean and the median are the ones that we will deal with most and in the upcoming sections, but we're going to mention mode and mid-range also. So the mean of a data set is the same as the average. So before I show you the scary math definition that we have now for mean, just remember, when you find the average of 2 numbers, what do? You add them together and then divide by 2. If you have the average of 3 numbers, you add them all up and divide by 3. So that's all that we're doing when we find the mean of a data set with this formula. This just says we're going to take the sum of all the xi's, where each xi is just a member of the data set that we're interested in, and then we're going to divide it by n, where n is the total number of things in the set. So this summation notation that we have in the numerator there, this big sigma means I'm going to take this sum from I equals 1 to n of all the xi's. That just means I'm going to add up x1 plus x2 plus x3 all the way up to xn, where your x's are just all the things in your data set. In the coming sections, it's going to be important to note the difference in these 2 means. A sample mean, remember from 12.1, a sample is a subset of the population that you're interested in. The sample mean is going to be noted with an x and a bar over it, and we pronounce it x bar. And the population mean is going to be denoted mu. So if you actually know the average height for your whole entire population, you would use mu. For instance, if your population is simply people on the football team and you're actually able to measure all of their heights and find the average height. However, if you don't investigate every member of your population and you just take a sample and report the mean of the population via the mean of the sample that you found, we call that x bar. But the way that we find these is the same. So let's do an example. Let's say the ages of adults in a random sample are given below, and we want to find the mean of all their ages. So we've got 1, 2, 3, 4, 5, 6, 7 people, and their ages are given here. So n is 7, so we're going to divide by 7, and then in the numerator, we're just going to add up all of those ages. So let me grab a calculator. $30 plus 31 plus 27 plus 27 plus 53 plus 52 plus 28 divided by 7, 35.4. So the average age of the people in this group is 35.4. Recall from last class the idea of a frequency distribution. A frequency distribution, see if I can give you one to glance at, is a table that tells us the number of data items in a particular class. So if we're given a frequency distribution like this, we can compute the mean of our data set by multiplying all the items by the number of times they occur, their frequency, and then dividing by n. So in this formula, each xi is a data value, fi is the frequency that value occurs, And then n is the total frequency of the data, or the total number of things in the set. So let's say we want to find the mean for the data in this given frequency distribution. Let's say these are my scores, and these are the frequency with which they occurred. So there are 1, 2, 3, plus 4 is 7, plus 4 is 11, plus 1 is 12. There are 12 scores that I'm going to take into account. 1 score is a 50, 4 scores of 40, 4 scores of 33, and 3 scores of 30 is what we had in our data if this is the frequency distribution that we were given. So to find the average here, we're going to multiply the score by the frequency and then add all of those up together. So we'll have 30 times 3 plus 33 times 4 plus 40 times 4 plus 50 times 1, and then we're going to divide all of that by 12. Notice this is the same in the numerator as adding 30 plus 30 plus 30 plus 33 plus 33 plus 33 plus 33. So it's the exact same formula for finding the mean that we are used to, just a little different notation. So 30 times 3 plus 33 times 4 plus 40 times 4 plus 50 times 1 is 432. And then when I divide that by 12, I get 36. So from the frequency distribution, the mean of my data for all these scores is a 36. The next measure of central dispersion that we want to consider is the median. The median is the middle item when your data is arranged from least to greatest. It's the number that falls right in the middle. So how we find the median, step 1, we need to put our data items in order from least to greatest. If the number of items that we have is odd, the median is just the number in the middle. We have a middle number in the set. For example, if we have 5 numbers, we can walk our way to the middle, and the number right in the middle is what we would call the median if things are ordered as they are here. If we have an even number of items, the median is going to be the mean of the middle 2 items. So we would make our way in to the middle 2, and now we're going to take the average of these 2. So the median is going to be 90 plus 92 divided by 2, which is 91. Let's look at this example. We want to find the median age of college graduates in a sample. So we've got 1, 2, 3, 4, 5, 6, 7, 8. In case we want this for later, n is 8 in this example. So to find the median first, we're going to order the data. So let's see, what's our smallest number? 21, and how many of those do we have? 1, 2, 3, 21, 21, 21, 22, 22, 30, 31, and 38. Now we have everything in order. The median, since we have an even number, the median is going to be the average of the middle two items. Our middle two are 22 and 22. They're the same number. So the average is just going to be 22 since they're exactly the same. Let's find the mean for this data set and then compare that to the median that we got here. So if we look back up at our list to find the mean, I'm going to add all of these together and divide by 8. So that's going to be the sum of the ages divided by 8. So if I add up all those ages, +21 plus 22 plus 30 plus 21 plus 21 plus 22 plus 31 plus 38 is 206. Divided by 8 is 25.75. So the median tells us the number right in the middle. 50% are above, 50% of the data are below. And so if we have a group of 8 people, 4 people are at or below this number, 4 people are at or above this number. The average doesn't tell us much about the distribution, and we're going to talk more about the normal distribution and when the mean and the median are the same or are not the same in the upcoming sections. But I want you to note here, because we have these outliers, 38 is fairly old for a college graduate, and then we have 2 others that are relatively high. That pulls the mean away from the median. So if your data is skewed and we have outliers above, or we could have had outliers at the bottom, it's going to pull the mean, the average, in the direction of the outliers. So our median is over here. But our mean is pulled up because of outliers that we have. And we'll probably talk about that more in upcoming sections. If your data is normally distributed, meaning it's symmetrical, your mean and your median will be closer to on top of each other. Oh, and all right, we would call this skew if it's not symmetrical. Two other measures of central dispersion, just 2 little easy definitions. The mode is the data value that occurs most often in a data set. Sometimes we don't have a mode. Sometimes all the data values, data points, just occur once. In this particular one, though, we have 1, 2, 3, 4, 5, 6 numbers given. And 74 shows up 3 times, so more than any other. The mode is 74 just because it is the number that we see most often. The mid-range is the mean of the maximum and minimum values of a data set. So if we want to find the mid-range, we need to find the minimum and the maximum value and then take their average. So let's look at this set here, 18, 74, 78, 81, 92, 95, I could order these if oh, they are ordered. Perfect. So my minimum is 18. My max is 95. So the mid-range is 95 plus 18 divided by 2. $56.5. Just for fun, what's the median in this same example? 1, 2, 3, 4, 5, 6. We have 6 items, so the median is the average of these two numbers in the middle. 78 plus 81 divided by 2 is 79.5. The mean is the average, so I'm going to sum up everything and divide by 6. So 18 plus 74 plus 78 plus 81 plus 92 plus 95. 438 divided by 6 is 73. And the mode there's no number that occurs more than once in this set. So there's not a mode. That is all for section 12.2. So take a look at the MyLab homework, and I will see you in our Q&A